All right. So at the end of part 10, we were looking at atomic radius, and just wanted to show you a graph here. Here's along the x-axis, this is your atomic number, and along the y is your increasing radius in picometers. So let's just take the first, no, let's take the second row, the second period. So this would be lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. As you can see, as you go across that row, the radius decreases. And you see that in general. Now, of course, there are exceptions to the rule, but in general, we see a decrease, and then it goes crazy down here with the F block, but we're not worried about that. Just the basic idea. The general idea is left to right, radius decreases, and then as you go down the first column, let's say hydrogen, lithium, sodium, potassium, and so on, you see that the radius increases. So it's pretty easy to see the trend when looking at the graph. Now, ionic radius is still the same measurement, but it's after the atom has gained or lost electrons. So let's think about that. When an element loses an electron and it becomes positive, its radius goes down. If an element gains an electron, its radius goes up. And then we'll look at a graph here in a second, but let's say I'm sodium. Oops. Let's say that I'm sodium here. All right, sodium. So 1s2, 2s1. Excuse me, 1s2, 2s2, 2p6, 3s1. So it should be pretty easy to see that since this electron is in the third energy level, we know that the third energy level is farther away from the nucleus, that once it's gone, once it loses that electron, now the outermost energy level is the second energy level. So we see, obviously, that when you lose an electron, your radius is going to decrease. Something smaller like lithium, 1s2, 2s1, lithium, 1s2, 2s1, we see, okay, it's going to lose this electron, so now it drops from the second energy level to the first, so its radius goes down. If it gains an electron, the radius goes up. Well, let's look at that. Previous. Let's do this. What about fluorine? Fluorine would be 1s2, 2s2, 2p6. Oops, sorry. That would be 2p5. Alright, so if it gains an electron, it changes from that to, of course, it would be negatively charged. 1s2, 2s2, 2p6. And the reason that the radius gets bigger is, well, you don't have an extra electron floating around there, so negatives repel other negatives. So if you have a bunch of negative charges and you're adding more negatives, what are they going to do? They're going to spread out. So when it spreads out, it causes the radius to be bigger, the atomic radius, ionic radius to be bigger. Now, for ionic radius going down a column, it's the same as atomic radius. It increases going down a column for the same reason. You're adding an energy level each time. The trend going across is a little different. It basically follows the atomic radius trend from 1 to 14. It decreases, in other words, because most of these elements that are in this up to 14 will tend to lose electrons. But starting with column 15, you get into nonmetals. And nonmetals tend to want to gain electrons. So when they gain their electrons, the radius increases. So ionic radius going down a column, as you can see, gets bigger. Very easy to see that. But as you go from, let's say, column 2 going left to right, you see the radius decreases in general. And then all of a sudden there's this big jump. When you get to nitrogen, nitrogen tends to want to gain those electrons when it reacts instead of losing them. So we already said earlier, if you gain electrons, you have more negative charge. And if you have more negative charge, that means there's more repulsion going on, so the radius gets bigger. So as you can see, in general, it's the same trend as atomic radius, except this little blip on the radar. It goes up right here, and then continues on a downward trend as you go from left to right. Alright, so that's atomic radius. That's part 10. We'll move on to part 11 soon.